Let's see Booth's multiplication. And this is Booth's multiplication algorithm. So why is Booth's multiplication used? So actually it works efficiently with signed numbers. If there are two signed numbers, that means signed number means two complement form, numbers were in two complements form, then this is much easier to multiply two signed numbers. So what here mean the process, like how do we multiply general multiplication? We generally add those number of times. If we have to multiply 3 to 2, then what we will do, we will add 3 two number of times. But here in Booth's algorithm, it mainly uses three operation: addition, subtraction and shifting, depending on their bit pairs. So how does it work? So for a multiplier of n bits, just let's see, if there are multiplier, there is two terms, multiplicand and multiplier. So like if you have to multiply 4 into 3, then here multiplicand 1 we will consider multiplicand m equal to 4 and multiplier q equal to 3. So we will calculate number of bits in signed form. So what is 4 100 in signed form? This will be, and 3 1 4 bits. So this is taking 4 bit. So n bit is there. So we put one extra bit, that is called q minus 1. See, we will consider here q0, q1, q2, like this, q3. So q minus 1 will be one extra bit. Here we have to put 0. And we have to compare each bit of multiplier qn with the bit to its right. That means qn minus 1. And based on the pairs qn minus 1, we will decide the action. Like if we take any bit qn, then we have to consider just right bit of this one, that means qn minus 1. So how many possibility can be there? 0 0 0 1 0 1 0 1 and 1 0. 4 possibility can be there. So for 0 0 and sorry, this should be 1 no? 1 1. For 0 0 and for 1 1, there is no addition or subtraction. We have to just shift right. No addition or subtraction, just shift right. Here also no addition or subtraction, just shift right. Okay. And if this is 0 1, this is 0 1, so in case of 0 1, we have to add the multiplicand to the accumulator. We will take one accumulator of n bits. It will start with all zeros. So this one, add multiplicand to accumulator. That means multiplicand is m, so we have to add with accumulator. That means accumulator will be accumulator plus multiplicand, and if it is 1 0, then subtract multiplicand from the accumulator. Subtract multiplicand from accumulator. That means accumulator will be accumulator minus n. Okay. How we have to think? Just 0 1, that means this is positive bit, so we have to add 1 0, this is negative bit, sign bit, so we have to just subtract. So just see the pseudo code. of this algorithm. How this will work? We have input for multiplication, what? M, this is multiplicand, Q multiplier, and N will be number of bits in signed form. Okay. And output will be product. This will be result of M into Q. We have to find out. So just say it's pseudocode boots multiplication. First, what we have to do, initialize. Here accumulator we will initialize with 0. This accumulator will be of n bits. Okay. Q minus 1, initially it will be also 0. This is extra bit to the right of Q. And one step counter. This will be initialized to 0. A step counter. Second, we will go inside of for loop for a step counter. For a step counter equal to n down to 0. That means if there is a step counter n bit, n is 4. That means 4 times this will go. So we have to check here what Q0, Q minus 1. We will check this one, and accordingly if this is 0 0 or 1 1, then we have to just shift. So here shift we will always do nothing. Okay. And if 0 1, then we have to add inside accumulator the multiplier, and if 1 0, then we have to subtract multiplicand from accumulator. Okay. And we will do always arithmetic right shift. Arithmetic right shift after all the process. A Q, we will see what is arithmetic right shift by 1 bit, and decrement the counter value. Decrement a step counter, and my result will be final result will be concatenate the value of accumulator and value of Q, that is multiplier. Okay. We will change the value of accumulator and Q accordingly. See here it is shifting now. So what is arithmetic right shift? If just consider any binary number 1 1 0 like this. So arithmetic right shift means we have to just shift right side 1. So this 0 will be extra bit. That means this will be ignored. So right shift 0, this right shift 0, this right shift 1, and this same term will be again repeated. That means its arithmetic right shift by one term will be 1 1 0 0. If we consider 0 1 1, its arithmetic right shift will be, just ignore this one, ignored this one 1, this one 1, this 0, and again 0. So its arithmetic right shift will be 0 0 1 1. So last bit will be as it is. Okay, and we have to just shift one bit right side. So it will work like this one for arithmetic right shift. Just see one example, then we will understand better. So I take multiplier m equal to 4. At first take multiplicand. We will write down properly. Sorry. Take multiplicand m 3. So its binary term will be 1 1 0 0, and multiplier q. This we take 4. This is 1 0 0. So this is 4 bit. Okay, we have to take sign bits, so I have taken 4 1 extra 4 bit here now. And what is my goal? M into q, so its value should come to 12 now. 3 into 4. So initial step, what is your accumulator value of 4 bit? 0 q. What is q? 0 1 0 0, and q minus 1 we will initialize with 0, and a step counter n number of bits, so 4. Just say its process here in table form. So we will move like this: a step counter qn, whatever terms we will consider, or q0. Let's take q0. Q minus 1, what will be its operation? Accumulator, then q, and then q minus 1, and we will comment here what process we are doing. So first step, we will start from 0. Okay, our step counter initial value is 4, and initially q, just say q is what? 0 1 0 0. So here initial q0 is 0, q minus 1 we have initialized with 0, so 0 0. In this case there will be only shift only. Accumulator is 0 and q is, so we have to shift now. So here see, accumulator is 0 0 0, and q is here 0 1 0 0, q minus 1 is 0. So we have to shift accordingly one right side, arithmetic right side. So this will 0 will come here, and accordingly 0 1 0 0, this will be 0 0 0 0. So this is shifting like this. So here this q will be 0 0 1 0, and this is 0. Here what we have done, no addition or subtraction, only shift. Okay, next a step 1, a step counter will be 3, and q0 is here 0, and q minus 1. For this will be q minus 1, it just its next term. This is 0, again 0 0. So again only shift only. So again we will shift, this 0 will come here 0, so it will start with 0 1 0 0 0 0 0, and this will be all 0. Okay, Here also no addition, same process. A step 2, a step counter will be 2. Here this q0 is 1, just its right term 0 1 0. Here this will be subtract from accumulator multiplier. Okay, we will subtract from accumulator. What is multiplier? Multiplier is 3 and accumulator is 0. So how we subtract? Just take 2's complement of 3. M is here 0 0 1 1. So we have to calculate minus m. So minus 1 m, by how we will calculate 2's complement? So 2's complement, what will be its first 1 complement? Sorry, 1 1 0 0 and then add 1. This will be 1 1 0 1. So this is minus m and just add with accumulator. Accumulator is 0 0 0 and this is minus 1. This will be 1 1 0 1. Okay, so accumulator will be 1 1 0 1 and q as it is, just take here. So what we have done, we have subtracted from accumulator. We have subtracted from accumulator. Okay, accumulator was 0 0 0 and multiplier we have subtracted 3. And then again we have to shift. So do it shifting. This one will come here, 0 0 and this one will come here, and 0 1 1 and this one repeated. This is arithmetic right shift. Okay, next step, a step counter will be 1. This 0 will be come here 0 1. So we have to add inside accumulator. So just add to accumulator. What is accumulator value? 1110. And what is m3? 0 0 1 1. If we add here 1 0 1 0 0 1, just neglect this one. And so what is this one? 0001. And q is here 1000. Here become 0001. Q is same 1000. We will shift again. What? 1. So what we have done here, we have added inside accumulator and shift now. So after shifting, this will become 0 0 0 1 1, all 0 here. So in next step, step counter will be 0. So this is end. Okay. So what is our final result? Goal is 12, no? And what is result? Concatenate A and Q. So A is here all 0 and Q is here 1 1 0 0. So result will be AQ. This will be 0 0 0 1 1 0 0. So its value is what? You can ignore this one also. This is signed weight, so just let it be 0. So what will be its value? 1 2 3 8 plus 4 12. So this is 12. And what was our goal? 3 into 4 equal to 12 also. So we have found out the